Use the discriminant to predict the number of horizontal intercepts for each function. Then use the quadratic formula to find any horizontal intercepts. Well, first of all, notice that each of the functions in parts A through B are quadratic functions. A quadratic function can be written in the form y is equal to ax squared plus bx plus c, where the leading coefficient a is not equal to 0. In this exercise, we're asked to determine the number of horizontal intercepts for each function, and then to find any horizontal intercepts. Well, when we graph a quadratic function, the graph is a parabola, and that parabola can either have no x-intercepts, one x-intercept, or two x-intercepts. Now, each intercept will have a y value of 0. So the strategy that we'll use to find the intercepts is to substitute 0 for y in the quadratic function. When we substitute 0 for y in the quadratic function, we end up with what's called a quadratic equation, and it has the form 0 is equal to ax squared plus bx plus c, where the leading coefficient a does not equal 0. In order to solve a quadratic equation, we can always use the quadratic formula. The solutions to the quadratic equation are given by the quadratic formula. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. The expression under the radical, b squared minus 4ac, is called the discriminant, and we can use the discriminant to determine the number of solutions to the quadratic equation. If the discriminant is positive, then there will be two real solutions. That's because when we take the square root of a positive number, we get a real number, so when we add or subtract that real number, we'll end up with two different solutions, and it will be the case that the quadratic function will have two horizontal intercepts. If the discriminant is equal to 0, then there's only one real solution. If the discriminant is 0, the square root of 0 is the number 0, and regardless of whether we add or subtract 0, we end up with the same quantity, and so there's only one solution for x, and therefore the quadratic function would only have one horizontal intercept. If the discriminant is negative, then there won't be any real solutions. That's because the square root of a negative number is not real, it's imaginary, and so we would have complex solutions, and therefore the quadratic function would have no horizontal intercepts. For a, we have the quadratic function y is equal to 2x squared plus 3x minus 5. To find the horizontal intercepts for the function, we need to substitute 0 for y. We get the equation 0 is equal to 2x squared plus 3x minus 5. This equation is already in standard form. We can see that the a value is 2, the b value is 3, and the c value is negative 5. So we can use the discriminant to determine the number of real solutions. The discriminant is b squared minus 4ac, so we'll substitute 3 for b, 2 for a, and negative 5 for c. When we do the arithmetic, we get the number 49. Since 49 is greater than 0, that indicates that our quadratic function will have two horizontal intercepts. To find the horizontal intercepts, we can use the quadratic formula. We'll substitute 3 for b, 49 for the discriminant b squared minus 4ac, and 2 for the letter a. When we simplify, we get negative 3 plus 7 over 4, or negative 3 minus 7 over 4. Therefore, our two solutions are 1 and negative 5/2. That means that the two x-intercepts are 1, 0, and negative 5/2, 0. For part B, we're given the function f of x is equal to negative 16 plus 8x minus x squared. To find the horizontal intercepts, we substitute 0 for the dependent variable, which in this case is f of x. We get the quadratic equation 0 is equal to negative 16 plus 8x minus x squared. To predict the number of horizontal intercepts for the function, we'll find the discriminant. We'll substitute 8 for b, negative 1 for a, and negative 16 for c. We find that the discriminant is equal to 0. That indicates that the equation has one real solution, and that will correspond to the one horizontal intercept of the graph of the function. To find the horizontal intercept, we'll use the quadratic formula. We get negative 8 plus or minus the square root of 0 divided by 2 times negative 1. This all simplifies to the number 4. So the one horizontal intercept is the point 4, 0. For c, we're given the quadratic function f of x is equal to x squared plus 2x plus 2. To find the horizontal intercepts, we first of all substitute 0 for the dependent variable f of x. To predict the number of real solutions to this equation, we'll use the discriminant. We'll substitute 2 for b, 1 for a, and 2 for c. We get negative 4, which is less than 0. Therefore, this quadratic equation does not have any real solutions, and the quadratic function will not have any horizontal intercepts. For d, we have the quadratic function y is equal to 2 times the square of x minus 1 plus 1. To find the horizontal intercepts, we'll substitute 0 for y. In order to use the discriminant to predict the number of horizontal intercepts, we'll need to rewrite this quadratic equation in standard form. First of all, we'll square x minus 1. When we square x minus 1, we get x squared minus 2x plus 1. Next, we'll distribute 2 through the parentheses. We get 0 is equal to 2x squared minus 4x plus 2 plus 1. Finally, we combine the two like terms. 2 plus 1 is 3. So the equation in standard form is 0 is equal to 2x squared minus 4x plus 3. Now that the equation's in standard form, we can clearly see that a is equal to 2, b is equal to negative 4, and c is equal to 3. So now we evaluate the discriminant. The result is negative 8, which is less than 0. Therefore, this quadratic function does not have any horizontal intercepts. For part E, we have the quadratic function g of z is equal to 5 minus 3z minus z squared. To find the horizontal intercepts, we first of all let the dependent variable g of z equal 0. We get the quadratic equation 0 is equal to 5 minus 3z minus z squared. We can see that a is equal to negative 1, b is equal to negative 3, and c is equal to 5. So we substitute those values into the discriminant and then evaluate. We get the number 29, which is bigger than 0. Therefore, the quadratic function has 2 horizontal intercepts. To find the 2 horizontal intercepts, we can use the quadratic formula. We find that x is equal to the opposite of negative 3 plus or minus the square root of the discriminant, which is 29, all over 2 times our a value of negative 1. We get 3 plus or minus the square root of 29 over negative 2. We can distribute negative 1 into each term in the numerator, and our end result is negative 3 plus or minus the square root of 29 all over 2. Therefore, negative 3 plus the square root of 29 over 2, 0, and negative 3 minus the square root of 29 over 2, 0 are the 2 horizontal intercepts.